In this video, I will try to discuss 5 items which are required to study equilibrium in statics. So, my first item is equilibrium. What is equilibrium? So, equilibrium means like in a body, in any direction, there will be no unbalanced force. To expand this, or this is a technical term. If I tell you in plain language, is that if I apply force on a body in different direction, different ways, the body will not move, and the body will not fly like this. Like the body will be in a stable condition. That is like plain language. In technical language, we call there will not be any unbalanced force in any direction. In other way, the applied force and the reactive force on that body will be equal in any direction. So in different ways I can explain equilibrium. So okay, so if I have a body like this, there I have a ground surface here. Say there's a body here. If I apply some force here, different ways, even I can twist something. So after applying different kinds of force, if my body does not move this way, that way, this way, that means the applied force and the reactive force by the body, they are equal. So that is called equilibrium. In plain language, after applying some force, if my body does not sink, does not fly, does not go this way, does not go that way, that means the body is in equilibrium. That is the concept of equilibrium. Uh, Second thing I will discuss is particle. So particle and rigid body. Like what is this? By particle we means like very small tiny particle. In engineering statics, particle doesn't mean very tiny particle. But typically it is a small body. It can be big body also. So actually small big does not matter. Matter is the concept. If I have a body, say whatever the body is, say a ball is a spherical ball. If I have a body, in all the points in the all the points in the body have the same characteristics, then we call it is a particle. Okay, so practical example, say there is a cylindrical pipe. Cylindrical pipe, I am carrying it using some device. This is a particle device, and this is a similar to lever arm. So this is a cylindrical pipe. Cylindrical pipe. Okay, right here, cylindrical pipe. So it is, it goes that way. So a particle here and a particle here. Sorry, not particle. A point here and point here. This point have same type of characteristics. So we can consider it is a particle. What is rigid body? Rigid body means a body that is rigid. Rigid means it doesn't deform so much. The deformation after applying load is so small, and different points in that body have a different characteristic. Say truss. So you saw this kind of truss in many building. This kind of truss, very plain truss. So this member and this member X and Y may not be same. Even this member and this member may not be same. So here this member and this member is quite different. So this one we can consider it's a body. It's a body. What is rigid? Rigid means the deformation on this body is very small. So we can consider it rigid body. Now something else. Is it important to know the difference between particle and rigid body in engineering statics? No. If you call a particle a rigid body, no problem. If you call a rigid body a particle, although it doesn't sound good, but there is no problem. So concept, it is just a like term. So if you use the right term, people will understand that you know the right thing. Okay, so equilibrium done, particle done, rigid body done. Next is idealized structure. It's very important. Idealized structure means we will simplify a real structure. Say if there is a structure which is very complicated, can we draw in whiteboard? Can we draw in paper? No. So we cannot draw the actual structure. So and also actual structure is very complicated, and we simplify it or make some assumption on it. That is called idealization. For example, say there is a beam here. It is supported by a two column, and one person was standing here. One person is standing here. So this is a actual structure. I will say this is a actual structure. Actual structure. But to do the analysis, we need to make some simplification. Say we are concerned about designing this beam. This beam. Then what will be the idealized structure of this? So we can draw this. So here the support, the column is support. We will assume the characteristic of this support. Say this is a roller type support. Say this is a pin type support. Now, how do I know this is a roller? Actually, I have to go there. If the two bar is just placed like this, I can consider a roller. If there is a nail here, I can consider it is a pin. So I do not know it, but that is the safest or most conservative assumption. So this beam, I represented by a line just. This support by this roller, I assumed it that it might be a roller. This can be roller, this can be a pin. So unless I go there, I cannot be sure. But I can assume that it is similar. And then this load. Say this person is standing on the beam and he has two legs. So he will apply load on two legs. But to make it simple, I can just assume that there is a concentrated load. Say this person is 150 pound. So I can insert 150 pound load here. So what I did here, this is called idealization. Based on the actual structure, I can simplify it and present it in a simple way so that I can analyze. So this is called idealized structure. So idealized structure, and this process is called idealization. What is that? Simplification of the actual structure so that the main characteristics is there and we can analyze it easily. Now for two leg, if we assume two load here like this, 75, is that okay? Yes, it is also okay, but it will be like more complicated. You have to know the distance between these two, you have to measure it on site. Or you can consider one load. It depends on the how precious this beam is, how accurate do you want it. Based on that, you will do your assumption. So hopefully you understood idealized structure. Our next part is free body diagram. So free body diagram, this is very important. You must know it. You must know how to draw free body diagram. What is that? It is one step further of idealized structure. So actual structure, then idealized structure, then we can draw free body diagram. It is telling you the meaning. Free body diagram. Free. The body must be free from any constraint, any restraint. So there is a restraint here, support. We need to move it. If we move it, that will be free body. So we know that a roller support can apply restriction in one way. So there is a force here. So I have load here. You can assume 1, you can assume 2, whatever you assume, that is not a problem. Then here I have a pin support, so 2 unknown. That means pin support can restrain in 2 ways. Can I assume this way? Yes, there is no problem. This arrow direction doesn't matter. After solving, we will know the exact direction. Just assume this way or this way, we do not know before that. So the arrow direction doesn't matter, matter is the arrow. Now this is the free body diagram. Free body diagram. I made my idealized structure or actual structure free from support, showed all the unknown reaction. Now something else. Oh, you can give a name. Say this is reaction 1, this is reaction 2, this is reaction 3. Name, you can name your own way, whatever way you like. If you see this is A, this is B, you can also name it A, Y. You can name it B, Y. You can name it B, X. This is more popular in United States. People go by AY, BY, BX. X means horizontal axis, Y means vertical. Now the arrow direction doesn't matter. You can assume whatever direction you like. After solving, if you get positive, that means your direction is right. If you get negative, your direction is opposite. Okay, so hopefully you learn what is free body diagram. Make the body free from the support and show the unknown reaction. That means if I summarize, so showing all the active force and reactive force on a body is free body diagram. So make your body free from support, show all the forces on it, external and external applied force and the reactive force. That will be free body diagram. So read your book. In our next video we will try to solve some problem on equilibrium. Thank you.